All right, we good to go. Does anybody have any questions on homework? Anything? Any topic that doesn't make sense? Anything? Go ahead. Okay. Okay, sure. Yeah. Yeah. Got you. All right. Got you. All right, let's take a look. Yeah. Got you.
Sorry. Good. You said anything to our members.
You good, you good. If you go to the grades column, you'll see like what
And it'll show you all
questions.
instead of,
Yeah, yeah. So yeah, and then you see there you go. Yeah.
and it should be.
So the goal, your goal, yeah. So what you want to do?
David.
All right, got you. Okay. So let's take a look. All right, no worries. You mind if I submit it again just to see what's wrong? Okay, so we got the bottom right. All right, so it's just the top. All right.
Detour.
Yeah. So here's the question, you guys. It's the square root of x to the fourth, y to the fourth, times cube root, x squared, y to the third, times fifth root, x cubed. Let me just verify real quick. All right. And then they're asking for whatever the exponents would be. So you have a x to the r power, y to the s power. They're asking you like, what is r and what is s? That's what they're asking you. Here we go. Yeah, all right. So the first thing, what you want to do, right? You want to multiply, right? These monomials, right? But the problem that I have is that each one of them has a root on it, right? So this is one of those situations where it might be a little bit easier for me to change the root into a power, like a fraction power. So I'm going to keep this as x to the fourth and y to the fourth, but I'm going to raise this to the half power, right? So remember, whenever you have a root and you don't have a number that's there, right? Remember that that's it's assumed that that's a two, right? Because square root, so it's going to be to the one half power, right? So I'm just changing the roots into fraction powers. Next, I have the x squared y cubed. And this is going to be to the one third power, right? Because you see how that's the cube root, right? With a three. And then last, right? So I have the x cubed, and I'm going to raise that to the one fifth power, right? Because that's the fifth root, right? And remember, the index is your denominator of the root, right? Okay. Now, remember, whenever we're raising it to a power, it's kind of like it's not this, but it's kind of like we're distributing the power onto every part of the term, right? So individually speaking, this is going to be what? X to the fourth raised to the half power times y to the fourth raised to the half power. And do the same thing to the other ones, right? Times, open parentheses, x to the second raised to the 1/3 power times y to the third raised to the 1/3 power. And I'm just going to keep the last one the same, right? This is just x to the third raised to the 1/5 power. So I hope it's a little bit more clear that each one individually is getting that individual power, who's being raised to that power, right? Now, whenever I raise a power to a power, what operation do I use? You remember? Whenever I raise a power to a power, hold on. Not add, multiply them, right? Bear with me 1 second, real quick. So let's just say, hypothetically speaking, right? I'm on the test, right? But I don't remember when I raise a power to a power, what do I do? You just come to your formula sheet. See right here where it says exponent rules? There goes the rule right there. A to the power n raised to the power m, right, is equal to a to the n times m power. So when you raise a power to a power, you multiply the exponents. All right, there you go. All right, here goes all your radical properties here. So you see, you don't need to like really memorize anything. Just look it up. If you don't remember, just look it up. You know, no harm, no shame in that. Sometimes I don't remember everything. You know. So for the first one, right? I'm going down right here. I raise a power to a power, so I multiply. What's 4 times half? 2, right? In case you're wondering, remember 4 is the whole number, so that's over 1. Then you just multiply straight across. So 4 times 1 is 4. 1 times 2 is 2. 4 divided by 2 is 2. So that's how I get that. Now, I should ask you the same thing for the next one, but it's the same numbers. So you already know it's just y to the second, right? Let's keep it moving, right? A little bit harder. So I have x squared raised to the 1/3 power. What's the answer going to be for that? Remember that the square is a whole number, so it's going to be like over 1. So what's the answer? X to the 2/3 power. Very good. All right. All right, a little bit harder now. So I got y to the third, right? Remember that's going to be over 1 because it's a whole number, raised to the 1/3 power. Excuse me, y to the yeah, y to the third power. Yeah, I said that right. Okay. Anyway, y to the third power times 1/3 is going to give me y to the what power? Y to the,
Third.
not the third. So 3/1 times 1/3 is 1, right? So y to the 1 power. All right. Last but not least, this is going to be x to the what power? Remember that this is x to the third raised to the 1/5. So it's like 3/1. So it's x to the perfect. All right. All right. So now I'm on this final line right here, right? Whenever I multiply exponents, what do I do with their powers? Add them, right? So let me just put these all together. This is going to be x to the what? To the 2 plus 2/3 plus 3/5 power. Does that make sense? Right? Because they're all being multiplied. So I'm just adding the exponents, right? For the x's. For the y's, I'm going to do the same, actually, right? So this is just going to be y to the second plus the first, right? Because there's an imaginary 1 right here. Does that make sense, everybody? And then after that, just a little bit of math, right? So it's like 2/1. So x to the 2/1 plus 2/3 plus 3/5. Let me ask you a question. What do I need to have in order to add fractions together? LCD, right? So what would the LCD be for this? 15, good, right? So to make a 1 into a 15, I have to multiply by 15. What I do to the bottom, I do to the top. To make a 3 into 15, I have to multiply by a 5. What I do to the bottom, do to the top. To make a 5 into 15, I have to multiply by a 3. What I do to the bottom, do to the top. Right? So this is going to be what? 15 times 2, that's like what, 30? Plus 2 times 5, that's like what, 10? Plus 3 times 3, that's like 9. All over 15, right? And then you already know that this is y to the third. I don't even need to continue with that, right? And then let's keep doing with the math. This is going to be 49 over 15. So x to the 49 over 15 times y to the third, right? But now for your question, it asks you what's r and what's s. R is the power on x, s is the power on y. So our r is going to be what? 49 over 15. And our s is going to be what? 3. Right? That's it. Yeah, that's it. So try it out. Did you get that? 49. Yeah. It's okay. Work? Mhm. Yeah.
I just plugged it in.
Gotcha.
A couple of inches.
Yeah.
And one change.
Yeah.
So, right, I was like, I must, I just had problems inputting it.
Got you. Got you. Got you. Yeah, yeah. So for the input now, for R, that's the one I'm thinking is an issue, right? You have two options. So they have that little bar thing on the right hand side, and you might see a bar that looks like this. Yeah, you use that one. Yeah, like you can make a fraction out of that. Or you could type the number, so like 49, and then do the slash on your keyboard and then write the 15, and then that'll make the fraction as well. Yeah. So yeah, you got options.
Just stay cool, remember that.
Mhm.
One question, like, I played it different ways.
Yeah.
Calculator, I couldn't.
Yeah.
And calculator was like start school.
Got you, got you. All right. It's not a bad question. All right. Let's look at what we getting into today. This question says simplify. I have 30 over 48. How do I do this? I have 30 over 48. What do I do? I want to simplify it. So how do I simplify a fraction? By 6? Okay, let's do that. So we know that 30 is what? 5 times 6, right? And we know 48 is what? This is like 8 times 6. The sixes will cancel. So I'm left with what? 5 over 8. Good. Any questions on this? Remember how to do this, right? You just factor the top, factor the bottom, cross out the like terms, you know? Same old, same old, same old. Oh, go ahead. Mm, I don't think so. Like, what do you mean? Let me ask for clarity. Yeah. Like you wanted to do something like this, maybe? Yeah, like you wanted to do something like that, you mean? With the parentheses and then is that what you mean? To to be honest with you, if I'm being frank, when I first saw this question, right? I didn't even see that the six went into it, to be honest with you. So, but I knew that it was 30 and 48. I knew that it was divisible by two. So, what I was going to do, right, was I was going to actually divide this by two. So, 30 divided by two is just what, 15? Well, 15 times two is 30. Think of it like that, right? And on the bottom, let's say 24 times two is 48. So, I would kill the twos. But now I'm looking at the 15 and the 24, and I'm saying to myself, like, three goes into both of those, right? So I know that the top, this is just 5 times 3, and the bottom, this is just 8 times 3, right? And then I just cancel the threes out like that, so I get the 5/8. So in my head, that's how I was working it out. But if you could see the six, I'm happy. You know? Yeah. Yeah.
I divide by two, and I see it 15 and 24, and I automatically go to five.
Yeah.
Because, we're knowing that.
Yeah. Got you. But yeah, so right. Yeah. So basically, like if you could see the big number, cool. If you can't, that's okay. Piece by piece till you get to the final answer. No problem with that. Yeah, that's still full credit. All right, let's try something else. We kind of did this earlier, but why not? Let's do it for fun. All right. So this is x squared times x to the fourth. All right. What does this become? Right, x to the six, right? And how do we get that? You just, anytime you're multiplying exponents, you add their powers, right? So 2 plus 4, that gives you your 6. Questions on this? Anybody? Good. All right, let's keep it going. Ooh, I definitely want to go over this. So we didn't do no shortcuts yesterday, but how we do this? Let's do it the long way. Tell me what to do. Mhm. Distribute, right? FOIL, very good, right? So 7 times 7, what's that? 49, very good. A little bit harder. What's 7 times negative 3x? Right, negative 21x. Very good. What about positive 3x times 7? Positive 21x. All right, last but not least, positive 3x times negative 3x. Negative 9, what? X squared. Perfect, right? Let's combine like terms. You notice how the two middle ones are the same? So they kind of just eliminate each other, right? So final answer, 49 minus 9x squared. And that's it. All right. Questions on this, anybody? This is the universal technique. It'll work for your questions, that you will have when you're doing your multiplication. Yeah. All right, so yesterday we did add, subtract, and multiply. Let's take a look at divide today. It's not that bad. So divide radical, expressions. So we have used the quotient property of radical expressions to simplify roots of fractions. We will need to use this property in reverse to simplify a fraction with radicals. All right. So we give the quotient property of radical expressions. Yeah, we give the quotient property of radical expressions again for easy reference. Remember, we assume that all the variables are greater than or equal to zero. All right. So that no absolute value bars are needed. All right, check this out. This is the quotient property of radical expressions. If the nth root of A and the nth root of B are real numbers, where B cannot equal zero, and for any integer of n greater than or equal to 2, right? Then the nth root of A over B is equal to the nth root of A over the nth root of B. And the nth root of A over the nth root of B is equal to the nth root of A over B, vice versa. All right? Questions on that? Sense? All right. If you're wondering, yes, it is on your formula sheet, so you don't got to memorize it. So we will use the quotient property of radical expressions when the fraction, right, we start with is the quotient of two radicals, and neither radicand is a perfect power of the index. So when we write the fraction in a single radical, we find common factors in the numerator and the denominator, if possible. All right. So let's just look at an example. So I'm looking at A, right? Just to recap, A is the square root of 72x cubed over the square root of 162x, right? Now, I could simplify the square root of each and then divide, but I'm telling you it's easier if I just write them all under the same radical, right? And I can do that because they both have the same index, right? They're both square roots. So this is equal to the square root, giant square root of 72x cubed over 162x. Now I can reduce this fraction on the inside and then do the radical. So let's do that, right? So if I'm reducing this big radical, right? I have 72 divided by 62. Let me think. It's another one of those situations where I'm just gonna cut it in half because I feel like that's just a little bit easier. So the top would be half of 72, I think is like what, 36, right? And then half of 162 is like what, 81, right? And then we have x cubed over x, that's just gonna be x to the 3 minus 1 power, always top minus bottom. So anyway, I have 36 and 81. I feel like a 3 will go into this, Maybe would 6 go in? No, 6 wouldn't go in. But 3 definitely could go into this, right? So this would be like what? Square root. I could factor out a 3. 3 goes into 36, I think, 12 times, and 3 goes into 81. Uh 27 times, right? Yeah. So I got the 12 over 27 x to the second power. I think I could go another time, right? I could do another 3. Yeah. So this would be like what, 4 over 9 x squared, right? Not too bad. Not too bad. No, we good, we good. But now check this out, check this out, check this out. I got the square root of 4x squared over 9. I feel like it'll make this pop a little bit more if I just rewrote this as a radical over radical. So square root 4x squared over square root 9. So this would be like 2x over 3. And then that's my answer. Yep, I got my, yeah.
What about if I move for X?
Mm-hmm.
What about if I move for X with two, maybe dividing by one?
Nah, that wouldn't be the final answer. But partial credit. No, yeah, yeah. 2x over 3. Yeah. Go ahead.
So each step, what you're really doing is taking the square out.
I'm dividing the top and the bottom by 2. Yeah. But I did that because I couldn't see the bigger number that goes into it. You know? Like if like 9 goes into both of them. I couldn't see that, you know? But again, if you can't see it initially, just piece by piece, little by little. No foul there. All right. You could show as much work as you want. There's no like cap on the, oh yeah, you can't write more than this, you know? Yeah. All right. Let's look at B now. All right. B looks like it's a little bit hard. I'm gonna change the color just so we're not confused, right? Now, B looks a little bit harder, but it's not really. So we have cube root. Hold on. 32x squared over cube root. Bear with me 1 second. 4x to the fifth power. Now I'm telling you, because this fraction has the same index, right? They have the same index on the top and the bottom. I can write them both under the same radical. So it should become like this: the cube root of 32x squared over 4x to the fifth. Now it's easier for me to reduce the fraction on the inside and then do the root, right? So let's keep going. So this is going to be the cube root of, what's 32 divided by 4? 15. Wait, hold on. Is it 8 really? Oh yeah, it is 8. Okay. Thank you. So now what about the variable right there, right? I have x squared over x to the fifth. It's going to become x to the, give me a better answer. 3 is good, but give me a better answer. Not 2. Remember, it's always top minus bottom, right? -3, right? So 2 minus 5, -3. Top minus bottom. Okay. All right. Now, I'm going to rewrite this as 8x to the -3 power raised to the 1/3 power. I'm changing the radical back to the fraction, right? Power, exponent. Now, again, it's not really distributing, but just imagine that everybody's going to get that power, right? So this is going to become what? 8 to the 1/3 power times, open parentheses, x to the -3 raised to the 1/3 power. And you know what? Upon reflection, it probably would have made more sense if I did the cube root of 8, because then that might pop a little bit more. So let me do that. So I want to make this as clear as possible. So let me do this as cube root 8. The cube root of 8 is what? 2, right? So this is just plain old 2. And then x to the negative 3 raised to the 1/3 power. Remember, negative 3 is a whole number, so put that over 1. Whenever you raise an exponent to an exponent, a power to a power, what do? What operation? Multiply, right? So I have negative 3 over 1 times 1 over 3, which becomes perfect. So this is just x to the negative 1 power, right? If I rewrite this, this would be like 2 over x. And that's it. Any questions on this? Now, you might look back on this and say, like, dang, like, I showed a lot of steps in this. You don't have to show all these steps. Like if you can look at something and understand it and give me the number, like, that's fine. You know? Like, the steps are more like to make sure that you guys are understanding individually? All right. How you guys feel? Like, was that good? Do you want to see another one or we can move on? One more? All right, so this is another example. Try this out. This says A is the square root of 50s cubed over the square root of 128s. That's A. B is the cube root of 56a over the cube root of 7a to the 4th power, right? So the easiest way to do this, write the fraction here under a single radical, simplify the radicand, what's there, right? That new radicand that you just found, and then apply the square root or whatever power, root power, onto every item in the term, right? Every piece of the term. All right, let's look at A. All right. So again, I want to write this under a single radical. So this is going to be square root 50s cubed over 128s. And tell me what to do after that. All right, I want to simplify. So good. By what? Five don't go into 128. Two, right? So you know that 50 is just what, 25 times 2? And 128 is just what, 64 times 2? So you already know the twos will cancel. Very simple. Then I have s to the third over s, which becomes s to the 3 minus 1 power, right? Because remember, we subtract top minus bottom. So here's what I got as my almost my final answer. This is going to be square root 25 s squared over 64. Now I can go back to putting the radical over both of these because it just became really, really simple, right? This is square root 25s squared over square root 64, right? So what's the top going to be? 5s. Very good. And what's the bottom going to be? 8. That's it, and I'm done. All right, 5s over 8. Yeah. All right. And then B, let me change the color real quick. And then B is going to be the cube root of 56a all divided by, right, the cube root of 7a to the fourth power, right? Now they both have the same index, right? The same index. So because of that, right, I can put them under the same radical, right? So this is going to be the cube root of 56a over 7a to the fourth, right? And then just go about, how you would do it, right? So 7 goes into 56 how many times? 8 times? All right. Does it really though? 14, 28? Yeah, it does. So this is going to be the cube root of 8 a to the what power? What is it? Not 4. Remember, top minus bottom, right? This is a 1. -3, right? So 1 minus 4, -3. After that, easy peasy, right? This is going to be the cube root of 8 times. Let's put the fraction power over here. This is 8 to the -3 raised to the 1/3 power. Cube root of 8 we know is what number? Very good. And then times a to the -3 raised to the 1/3 power is a to the what? Say it again. -1, right? And then just to make my exponent positive, remember we can't have negative exponents. This becomes 2 over a. And that's it. Any questions on this, buddy? Yeah. Okay. Gotcha. Yeah.
You said, what I did.
Nah, I had to think about it. Like that's why. That's
Tuesday morning.
Yes.
Yeah, can I?
Yeah.
I thought it would be everything.
Yeah. Tuesday.
Thank you.
Yeah, that's
Tomorrow.
yeah.
Tomorrow.
Yeah, the second one. Yeah. Oh, I clicked the wrong button. Give me 1 second, real quick. I clicked the wrong button. All right, so check this out, right? Now we're going to talk about rationalize a one-term denominator. All right. So before the calculator became a tool for of everybody of everyday life, excuse me, approximating the value of a fraction with a radical in the denominator was a very cumbersome process. For this reason, a process called rationalizing the denominator was developed. A fraction with a radical in the denominator is converted to an equivalent fraction whose denominator is an integer. So square roots of numbers that are not perfect squares are irrational numbers, right? When we rationalize the denominator, we write an equivalent fraction with the rational number in the denominator. This process is still used today and is useful in other areas of mathematics as well. So rationalizing the denominator. Rationalizing the denominator is the process of converting a fraction with a radical in the denominator to an equivalent fraction whose denominator is an integer, right? Blah, blah, blah. Long story short, it's illegal to have radicals in your denominator. So we can't have that. So we have to rationalize them. That's what we're talking about here. All right. Even though we have calculators available nearly everywhere, a fraction with a radical in the denominator still must be rationalized. It is not considered simplified if the denominator contains a radical. Similarly, a radical expression is not considered simplified if the radicand contains fraction. All right. So let's take a look at this real quick. I just want to sum this up one more time before I go over an example with you guys. Okay. So simplified radical expressions, all right? A radical expression is considered simplified if there are no factors in the radicand that have perfect powers of the index, no fractions in the radicand, right? Radicand, again, is that thing that's underneath the square root, right? And no radicals in the denominator of a fraction, all right? To rationalize a denominator with a square root, we use the property that the square root of a squared is equal to a, right? If we square an irrational square root, we get a rational number. Okay? Let's take a look. Let's take a look. So check this out. Let me do a, all right? So I have 4 over the square root of 3. Let's say that that's my answer, right? It's not my final answer because I have a radical in the denominator. I have to get rid of that square root of 3. So what do? Just multiply it by square root of 3 over square root of 3, right? And how do we multiply fractions again? Straight across, right? Straight across. So 4 times square root 3 is going to be 4 square root 3 over square root 3 times square root 3 is very simply just 3. This is my final answer. I did skip a step there, right? So in case anybody wants to know how did the bottom become 3, right? This was really just 4 times square root 3 over square root 3 times square root 3, which became 4 square root 3 over square root 9, because 3 times, so you just multiply the radicands. And then the square root of 9, that's the 3, all right? But if you want to just skip that step and go straight to the 3, like I did, go ahead. That's how I do it in my head all the time. All right. Questions on this though? Anybody? Make sense? All right, check this out. So let's look at B. Now, technically speaking, there's no radical in this denominator, but, right? If we rewrite this is square root 3 over 20. If we rewrite this as square root 3 over square root 20, now we got issues, right? Now, I'm going to show y'all my favorite way to do this, right? I like to reduce my radical first before doing my multiplication, right? Why? Because I don't like multiplying big numbers, right? So to make this a little bit easier, this becomes what? Square root 3 over square root 4 times square root 5. right? And what's the square root of 4 again? 2, right? So this becomes what? Square root 3 over 2 square root 5. Now, all I have to do, remember, what's the illegal part? The radical, right? The radical 5. All I got to do is just multiply by the radical 5 over the radical 5, and I'm Gucci, right? So, again, we multiply fractions straight across, right? Square root 3 times square root 5 is just what? Square root, what is it? 15, right? Now, on the bottom, this is going to be what? 2 times square root 5 times square root 5, which is what number? Square root 5 times square root 5. 5, right? And the final answer is 10, right? So this is square root 15 over 10. Very good. And that's it. All right. Questions on this? Anybody? Good? All right. Now I'm going to do a similar process with C. I kind of ran out of space, so for those that want to take pictures, y'all could I'm gonna do it up here for y'all, but look, you got to get rid of the radical in the denominator, right? Which is 6x. What you do to the bottom, you do to the top. Final answer, this is 3 square root 6x over just the 6x. But you know that you could reduce that 3 and that 6, right? So 3 goes into 3 once, 3 goes into 6 two times. So final answer is square root 6x over the 2x. And that's it. All right. Any questions on that? Anybody? Good? You feel like we can move on, or you guys need to see another one?
What's the equation denominator, the square root of the denominator, and redistributing or and then so fine.
Right. Let's see. So how we feel? We good? Good. All right, let's move on then. Mhm. Don't worry, I do have more examples though. We're not missing out. So we still talking about rationalizing the denominator, right? But now we're gonna take it up a notch a little bit, right? Just a little bit, not much, just a little bit. All right. So rationalizing a two-term denominator. When the denominator of a fraction is a sum or difference with square roots, we use the product of conjugates pattern to rationalize the denominator, right? So check this out. You know that a minus b times a plus b is a squared minus b squared, right? The same is true, right, for the product of conjugates. So if you have 2 minus square root 5 times 2 plus square root 5, it's just 2 squared minus the square root 5 squared, which becomes 4 minus 5, which equals -1. That's it, right? So when we multiply a binomial that includes a square root by its conjugate, the product has no square roots. This is my goal. I don't want a square root. So anytime I have a radical in the denominator, you multiply it by its conjugate, its opposite, right? Check it out. So let's say I have 5 over 2 minus square root 3. Now, I have a problem. I have a radical in my denominator, so I have to rationalize this. So I'm going to multiply this by what? See it? Uh-uh. Not that. The conjugate, the opposite, which is what? Right, so 2 plus the square root of 3. That's the opposite, right? But what you do to the bottom, you gotta do to the top. And then very simply, we're gonna multiply this. So you already know. Bam, bam, right? And then on the same thing on the bottom with the FOIL. So the top 5 times 2, that's 10, plus 5 times square root 3, which is just gonna be plus 5 square root 3. That's easy, right? But the bottom, imagine these are in parentheses, right? You're gonna FOIL this. So 2 times 2, right? That's gonna be 4. 2 times square root 3, that's going to be plus 2 square root 3. Negative square root 3 times 2 is going to give me a negative 2 square root 3. And then negative square root 3 times positive square root 3 will just give me a negative 3. If you want to go through it, it's technically negative square root 9, and then the square root of 9 is 3, blah, 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 right? Anyway, combine like terms. These two, you notice how they're the same, right? They're going to cancel out. So I have what? 10 plus 5 square root 3 over 4 minus 3, which is like 1, right? So my final answer is 10 plus 5 square root 3, and that's it. Questions on this? Anybody? A little complicated. You got to multiply it by the opposite, but FOIL it out and you're good. Good? All right. Can we move on or do you want to see another? Hmm? Another one? All right. All right. This one's a little bit harder, but not too bad. All right. Try that out. For the test tomorrow, remember you guys could bring your calculator, bring your formula sheet that y'all got. All right. And bring pencils or a pen or multiple pens, whatever you like. If you guys didn't get a chance to get a calculator as yet, remember that upstairs in the library you can borrow, right? The graphing calculator, the TI-83. Or if you guys have time to go to tutoring before the exam, you can ask them to see if they will lend you a calculator for the exam. All right. They have the 36X Pro that I always talk about in tutoring. Mhm. Also, it's not too late to hand in test corrections if you guys still want to. All right. I also dropped the lowest exam grade, so try your best. But if it doesn't go as planned, that's okay. That happens. Sometimes we all have off days. You know, sometimes it rains and the weatherman ain't say nothing to us. Left us hanging. For tomorrow's exam, I was trying to give y'all like 30 questions. And then I realized France is playing Morocco. I gotta get out of here. So y'all got 4 questions. Just knock it out real quick and then we'll be out. And that's it, just 4 questions. Pretty much. Mhm. Light work. Mhm. All right, let's try this out. All right. Oh, by the way, if I didn't mention this earlier, like this is not on tomorrow's exam. This is test three. This topic. Just y'all know. All right. For what? It's mostly just this and applications of this. Like it's just this stuff. Yeah. Yeah. You can get like 100 on this joint. You know? That's nothing. Mhm. All right, so look, I got 3/1 minus square root 5, right? Now, here's the issue. I got a radical in my denominator. I can't have that. So I have to rationalize it, right? So what am I going to multiply this by? Somebody tell me. Right. Good. Very good. Right. But you know what I do to the bottom? I gotta do to the top. Right. And then let me put it in parentheses. Maybe that'll make it pop a little bit more. Right. So you already know this is just gonna be distributed. Boom, boom. Right. Damn. What's this first one? What's 3 times 1 again? Three. Three? Appreciate that. Thank you. Thank you. Plus, then we have 3 times square root 5. It's gonna give me a 3 square root 5, right? Over. All right, that's the hard one now. Like, what's 1 times 1? 1. Appreciate that. All right, this is even harder. What's 1 times square root 5? Plus square root 5. Very good. What is negative square root 5 times 1? Hmm. What y'all think? 1? Good. Give me a better answer. Negative square root 5. Good. All right. Negative square root 5 times positive square root 5 is negative what? Not negative 3, negative 5, right? And then after that, combine like terms. You already know these two middle ones are the same, so they're going to just cancel out. So I have 3 plus 3 square root 5 over 1 minus 5, which is what? Negative 4, right? And that's it. You could give me the answer like this if you want to put the negative on the side, whatever. Like, I'm chill. Mhm. Questions on this? You could even distribute the negative in the numerator if you want. Whatever, the same thing. Right? But, all right. Let's take a look at another one. Ooh, this gonna be fun. Now, the hard part about this, right, is that they gave us the variable u, right? Y'all know my favorite variable is C for Chris, right? But we're gonna do U today, right? All right, so I have square root 3 over square root U minus square root 6. All right. So believe it or not, the square root 3, that's cool. No problem with that, right? But hold on, that's I could do better a better line than that. Yeah, that last line wasn't looking too good, right? But my problem here, right, is that square root of u minus square root of 6, I have a radical in my denominator. Worse, I have two radicals in my denominator. So I got to rationalize this, right? So I'm going to multiply this by what? square root u, not minus, plus the square root of 6, right? You want to multiply it by the conjugate. But we got to be fair. What we do to the bottom, got to do to the top, right? Square root u plus square root 6, all right? And then let me put it in parentheses just to make it pop a little bit. You already know, right? I'm going to distribute. I'm going to do the same thing on the bottom. So square root 3 times square root u is, say it again? Not 3 square root u. Go ahead. Square root 3u. Just like that, right? Plus, right? What's square root 3 times square root 6? Go ahead. Square root 9, not square root 9. 18, right? Square root 18. I'm gonna come back to that though. All right. Let's do the bottom. Square root u times square root u is what? It's not me, it's you. Soldier boy. Don't let me stop. Square root u squared, yes. And then the square will cancel out with the radical, leaving back just u. That's true. And then now we have square root of u times square root of 6, which becomes plus square roots 6u. And negative square root 6 times positive square root u is going to give me a negative square root 6u. And then last but not least, negative square root 6 times positive square root 6 will give me a negative 6. All right. It technically is negative square root 36, but you know, square root 36 is 6, all that good stuff, right? Let's combine like terms. You already know these two in the middle are the same. That's going to cancel out. So I have what? Square root 3u plus, now I could simplify that square root 18, right? Remember, square root 18 is just what? That's square root 9 times square root 2, right? And the square root of 9 is what? 3. So 3 square root 2 over the u minus 6. And that's it. We call it at that. Not too bad, right? I'm sorry? Yeah. Go back. Oh, yeah. Oh, you mean to the beginning like this? Yeah. Got you. You're welcome. You want to see the original question up here like that? Welcome. Yeah. Questions on this? Anybody? What? Yeah.
He did 92. I did it was 3 and 6. So it's the same thing. You just didn't know.
Yeah. So if you're gonna do the 3 and 6, right? Like do this instead. Like do the tree 3 and 6. You know, 3 is prime, and break down the 6, 3 and 2. So you know that the double 3 is gonna become 1 3 on the outside, and the 2 stays on the radical. Yeah. Yeah, that prime factorization tree, like that's the truth, you know?
Where, um, that sheet, you said to look at, where is that?
Oh, on the formula sheet? So you see right here where it says properties of radicals, right? So we're talking about this one right here. You see the nth root of a over b is equal to the nth root of a over the nth root of b. So this whole lesson is just variations of that one rule. Like we spent the whole day on just that, you know? Mhm.
And the, that's the NDB,
Mhm.
out of the,
Right.
goes NA to NB.
And nth root of a over nth root of b. This one right here. But let me highlight it. So that one. Yeah. On the properties of radicals. They're pretty cool, right? So if you guys have any questions, y'all could look it up. Y'all have all the information here for your test. Mhm. All right. So for nah, you gotta do it by hand. But you need the calculator for the numbers though, the timetables and all that. Yeah. I'll be over here counting my fingers and doing trees and all that for my multiplication. All right, so for this question, right? Do we feel good? Can we move on, or do you want to see another one? Good. One more? All right. All right, this one is a proper question. All right, this is a proper question because it has an x, right? So square root 5 over square root x plus square root 2. Go ahead, try that out. I feel like we're gonna have some good time to review for the final, so this is good. I do have a review sheet for y'all for like test 3 and the final, so y'all don't have to worry. Yeah, nah, they're not together. But each test gets easier though. Like the final's even easier than this. That's a good question. I don't know. Um, it's not next week. It's probably the week after next. Maybe. But we got some more topics next week, so can't do it next week. But I feel like we might like right after test 3, we could just focus on the final. Like no new topics to learn.
So wait,
Yeah.
that's 14.
Yeah.
Why is this?
I'm not sure. It's definitely not next week because I have more stuff to do. Yeah. And then the final, yeah. And then the final is on a Thursday. The 30th. Yeah. Yeah, that's the 30th. Tutoring is open, by the way, the day of the final. You know. Remember we had like voted on that Wednesday or Thursday? Yeah.
Well,
Yeah. Yeah. But I'll release it like after test 3. Yeah. But it'll be really, really easy. Don't worry. All right, let's try this out. So I have square root 5 over square root x plus square root 2, right? Now, this is a cool answer, but the problem is I got radicals in my denominator, so I had to rationalize it, right? So what do I have to multiply this by to get rid of the radicals in the denominator? What do we think? What do you think? I want the opposite. So what's the opposite of this? What? Right. So tell me what it is. It's the same thing, but with a minus sign. So square root, what? Not two, square root this one. All right, so square root x. And what's the sign? Minus. And then what? Square root of what? Two. That's it. Right? Same thing. Copy and paste. All right. But here's the hard part. What you do to the bottom, you gotta do to the top, right? So same thing. Square root x minus square root two. After that, just a little distribution and we good. Right? Distribute this. Square root 5 times square root x is square root what? 5x. Very good. And then square root 5 times negative square root 2 is what? So square root 5 times negative square root 2. Negative square root, say it? 10. That's it. Very good. Now on the bottom, right, we about to FOIL this. So square root x times square root x is just x. Very good. And then square root x times negative 2, square root x times negative square root 2 is what? Right? So negative square root 2x. Now positive square root 2 times square root x is what? So positive square root 2x. Now what is positive square root 2 times negative square root 2? So negative square root 4, which is negative 2, right? And then now let's combine like terms, right? So we're going to cancel out these middle ones right here because they're the same thing. You know, one's positive, one's minus, right? So final answer, I have square root 5x minus square root 10 over x minus 2. That's it. Not too bad, right? Hmm. You're welcome. Hey. All right, let's take a look at another question. How was your day? That's
Today I'm supposed to make it to whatever you need to.
Gotcha. Tomorrow. Okay, I'll see you. Have a good night. All right, let's try this question out. So I have square root x plus square root 7 over square root x minus square root 7. All right. So now I got a binomial divided by a binomial, right? Let me rewrite this. Over, right? Now, believe it or not, the numerator is cool. Like I'm chilling with my numerator, but that denominator, I got two radicals in my denominator. I got to get rid of them. So what do I have to multiply this by to get rid of those radicals? What do you think? What do you think? Yeah. So I want to get rid of the radicals over here in the denominator. So what do I have to multiply them by to get rid of them? Right? So square root x and square root 7. What's that sign? That's what? Positive, right? Always the opposite. Well, what I do to the bottom at the top, right? That's it. Mhm.
Negative.
Because it has to be the opposite of the denominator, the bottom part, not the top part. So like this is negative here, so that's why that becomes positive. Yeah. All right. So after that, you just distribute, combine like terms, all that good stuff, right? So square root x times square root x is just x. Square root x times square root 7 is going to be plus square root, right? 7x, are we good? And then square root 7 times square root x is going to be plus square root 7x. And then last but not least, square root 7 times square root 7 is just plus 7. All right? All over, let's do the bottom, right? So square root x times square root x is positive x. Square root x times square root 7 is going to be plus square root 7x. Negative square root 7 times negative x is going to give me a negative square root 7x. And then negative square root 7 times positive square root 7, that's just negative 7, right? Let's combine like terms, right? Let's combine like terms. So watch this. The top is going to be x plus 1, 2, 2 square root 7x, right? Plus 7 all over. These two will cancel out. X minus 7. That's it. That's my answer. All right. Any questions on this one? Go ahead. Okay. All right, no problem. That's fair. Okay. Mhm. So how do we feel about this question? Like, do we understand it? We want to see another one, or we can move on? What y'all think? Oh yeah, sure, sure. It's this one. Well, down or up? Which one?
So it's.
Like the previous question? I'm sorry, my fault. Well, if everybody understands it, then we'll call it a day at that. You got it? So just come sign out before y'all leave, and that's it for today. We have our exam tomorrow. Study hard. Mhm. I recommend the homework and the review sheet.
Oh, right.
Can I, real quick, can I take this down? Anyway, appreciate y'all. Y'all know I need time to download and all that stuff, so.